and maybe he could do his
Mm-hmm.
job a little bit faster or something that, you know, helps you out, or do something in his job when you're in a bad way that helps your process of your product.
So you built positive relationships with your team members.
Positive professional relationships, yes.
Okay. And did you improve communication in any way?
Well, I don't know if this counts, but generally I would ask people whenever I got a job. Like I said,
Mm-hmm.
I'm proactive in the sense that I would kind of run through that job and I'd look at, okay, what information do I need before I start, or what information am I going to need in the long term that this person might not be able to provide right away. So
Okay.
by going through the job in the big picture, right, I could
Mm-hmm.
identify, hey, I'm going to need this information, but this guy probably has to talk to a vendor and he's going to need more time. So I would basically at the outset get everything out there that I needed from people and give them the time to get this information to me, so that at the last minute I'm not asking for it and they're busy. And then I go to my manager and say, this guy won't give me stuff. Why? Because he's up against the wall, you know? So
No, this is a
I
really
find that goes a long way with people, but
it does. No, this is a really good point that you mentioned. Okay. And you already mentioned that you did take care of the documentation.
yes.
You managed that. Did you oversee any other special projects here?
Special, they were all special projects, but nothing, yeah. You know, I did work with I mean, it all comes under the same heading. I did work with a designer to create some of these fixtures. Um,
Okay.
you know, that helped speed the process, or, you know, limit the risk to flight hardware. I mean, basically sitting down, talking with him from what my requirements were, and also
Mm-hmm.
from my design background, I was really able to communicate with him, and we were really able to put that together so that it was something that was entirely usable and not just an impedance to the processes. Sometimes when people help you, that can be.
Got it. Got it. And can you think of anything else you would like to add for this experience before we move on?
Hmm. No, no, not at this point. I think we've covered most of it.
Okay, great. Let's move on to the designer job at LB Telesystems and All Metal Fabrications.
Sure.
Hello,
Yeah. Can you hear me?
I can hear you.
Okay. Yeah. Whenever you're ready.
I'm ready. You were talking about some tool that you created here.
Yes. So basically, as a fabricator, I came off the floor into the
Mm-hmm.
design role. Um, and what I found was that using their software package, I'm sure you've heard of SolidWorks. There's also Solid
Mm-hmm.
Edge. We use Solid Edge. It's equivalent to SolidWorks. It's just a different maker. So basically,
Okay.
what I was able to do is he had a standard product line. In other words, that he would outfit telecommunication vehicles, Red Cross vehicles, U.S. Customs, any type of van or mobile command center type situation. So he had a couple of standard products. What I was able to do is, through the use of the CAD software, I was basically able to establish parameters in a spreadsheet, which was within that software. And from the sketch environment, I could I could basically put different dimensions on that assembly and it would update instead of having to do it all over again from scratch. So
Okay.
that basically saved them a lot of time.
Okay. And what were your day-to-day responsibilities here?
Okay. So my day-to-day responsibilities were I would receive, let's say I received some type of order. I would
Mm-hmm.
access those files. I would make any kind of adjustments, dimension wise or whatnot. And I would issue that work out to the floor with fabrication prints. And
Okay.
I would also program any machines or make available any machine files, uh, and look at the router and say, okay, this is the correct order of things. I would take those out. I would communicate with the people who are making the parts. These were on standard things, but at that company, as you can imagine, they would take architectural work. They would take some guy comes in with an idea, some guy comes in with a unique piece. It was all prototype work. And I would sit
Mm-hmm.
down with that customer and they would have a little drawing or something like that. And the customer would communicate his requirements and his needs. And then basically I would take it from there. I would start and I would design it from scratch.
Okay.
And I would give them fabrication prints. And I would
Mm-hmm.
also, at some point, if they needed assembly instructions or fabrication instructions, I could provide those too. Because a lot of times those guys would come in, they would do their prototype in the US, and they would take all those fabrication instructions and prints over
Mm-hmm.
to Asia or wherever and have it mass produced. But we were part of the proofing process.
Okay. Okay.
Or they'd
That
come
makes
in,
sense.
yeah, or someone would come in case of electronics packaging, they'd come in with a box of parts and say, hey, I need this to fit in a budget of space.
And then you would design that.
Yes, yeah, and a lot of times because I had command of this software, I could
Mm-hmm.
throw a straw dog out there, within a day. And then that customer
Wow.
would come back and I could show them, hey, look, this part's going to fit here, this part's going to fit there. But when you have the tight budget of space, you also have to know, in the case of sheet metal, what tooling you have in that shop. You're not going to buy a special tool for this job. It's too expensive. So you've got to be able to be creative or have knowledge of, the order of bends or what type of, what's your minimum flange that you can bend with this equipment. What are some special tricks that you can pull if it doesn't work. So a lot of times that really came into, something that otherwise people would just throw out. Believe me, I worked in this job. They just throw things out on the floor and then it causes a bunch of problems, and a modification needs to be made at some point. So it really helped to streamline the process. I mean, my expertise was such that if I did have a job and I put it out on the floor, I mean, this only happened maybe once or twice. And a guy says, hey, you can't make this. I would go over to the break and I'd show him how or I would do it. And then I didn't get a lot of questions after that, as far as can we make it. They might come in and say, how did you envision this happening? But typically I would head that off and have a discussion with them while I was designing them.
Okay.
It was a great
That's
place to cut your teeth as a designer. I did work with other degreed engineers, some from, where was that guy from? Purdue. And they, oh boy, they didn't even know where to start. I honestly, I don't know how you design without some type of fabrication background, but that's just me.
wow. Okay. So let's start with the first point. You said you used extensive knowledge of sheet metal, and how exactly did you manage to streamline sheet metal design and manufacturing processes? You just discussed that.
Yes,
And
yes.
what
Just because I know how it's made.
exactly? And what effect did this have on operations in terms of time, cost, and efficiency? You also just explained that because since you knew what you were doing and what the process required, it eliminated all three of these things.
Exactly. Exactly. And not that I mean, nobody's perfect, but man, let me tell you, I was pretty good. And you know what? Even if
But
it came to a
obviously,
process that I wasn't an expert in, I knew, and
mm-hmm,
typically through anything that I'm working on, it's not always that you know the answer, but you know the right question to ask. And you go to the person to ask that question. And you look at them and say, hey, what kind of limitations do you have?
so you can work with what they have exactly, and then
Exactly. So
deliver.
you got to, yeah, like I said, if you don't know you might not know the answer to the question, but if you know the
Mm,
question, you're a lot better off than
e-
guessing.
exactly. That's so true in every aspect of life. Okay, so next is implemented a process using variable 3D models and 2D sketches in Solid Edge to provide information and evaluate different scenarios.
Yes,
So, what was
we've
this
kind of
process that you implemented?
well, we kind of talked about this, but
Okay.
basically it was the CAD modeling to be able to adjust certain parameters. Now, in particular, that airport job at Reagan National,
Mm-hmm, mm-hmm.
the architectural part of that company bid on that job and they got it. But we were working with, man, I wish I knew this guy's name, but he was one of the original architects or part of that crew. And boy, he was strict. So typically, what they do is they like to put up wood paneling and then clad it with metal. Okay. But
Okay.
th- that didn't work because when they hung test panels in the airport, the humidity with the type of wood that they used, it just warped all up. So in the brainstorming session, I was able to come up with a purely sheet metal design. If you see those panels in that picture, and a system of mounting them without exposed fasteners. What I was able to do with CAD is I was able to develop that idea using a sketch, okay,
Mm-hmm.
and just saying, hey, this thing is 100 feet long, and be able to demonstrate that idea very quickly using an adjustable sketch to present that idea. And then when it came to the time of actual fabrication of those pieces, I could take survey measurements, plop them in, and my parts would grow.
And what about the system that you developed to mount it? Can you talk
Uh,
about that?
well, it was a simple. The mounting system itself was rather simple, but the parts and the geometry on the panels was not. So it was a simple what we call a Z rail, and it was attached to the escalator. But
Okay.
I mean,
Mm-hmm.
you can see the finished product, but having a two-piece assembly and having them join it, what architecturally is called a reveal, was a nice feature. Those panels basically hung on rails and they sat close, tight to each other.
Okay. Okay.
I mean, the real power in this was the fact that no one was thinking sheet metal; everybody was thinking wood. So I was able
And
to take my experience and come up with an idea that was accepted and is still there today.
that's
but
amazing.
but I was also able to do it rather quickly using that the parametric quality of the software. I mean, I didn't invent the software, but very few people will start from a sketch environment and then use that sketch to develop their parts. They'll just go in there and start making parts, and then you got to change everything. This I was able to keep relationships and have parameters written out so I know if I was in violation or not of my own design.
Mm-hmm. That makes sense. So you sketched it out, then you developed the design, and you implemented it.
Yes, using the software, just using the tools and the software.
Okay.
They do something now. I believe in what's the high end software? Pro E. There was some talk. I mean, I didn't do any design work there, but there was some talk. It's basically, I think, in the business they call it using skeletons. And you take the
Okay.
skeleton and you modify it. But you know, don't put me down on that.
No, I won't. Okay. So next, you evaluated tolerances. And what methods did you use to do this?
Well, basically, I just used my knowledge of fabrication to say, hey, I need 30 thousandths clearance here because I know the bend guide's going to be plus 10, and I know the welder needs another 20 because I was the welder and I was the bender. So an important part of design is clearances, right? You
Mm-hmm.
can't make a 1 inch pin going into a 1 inch hole. Doesn't work
Mm-hmm.
that way. I mean, unless you want it to really stay there. So you have to be able to say, hey, look, I have a quarter 20 screw. I need a clearance hole for this. But you know, I've got two pieces coming together, and what reasonably can I expect from sheet metal fabrication? What reasonably can I expect in this machining process? What reasonably can I expect if it's a weldment? So
Okay.
yeah, that's important. I've been to that college class where that guy's trying to teach everybody that, but they just don't get it, man.
And then you designed jigs and fixtures for assembly speed and manufacturing precision. What steps did you take in designing these, and what was the result you accomplished?
Okay, well, if you were to take an odd area like the inside of an RV or the inside of a vehicle, and you have to make
Mm-hmm.
and you have to make a bunch of uh, let's say you have to make some type of assembly that goes in there and mounts all types of equipment. Well, kind of like what the counter guys do when they come in your house to replace your counter. They don't measure, but they make templates. So I would make measurements and then I would make a template punched out of some cheap sheet metal. We would go in there and we would fit that to the truck. And then I knew I had an envelope of space in which to design all these things that need to go together and look nice inside of there. That's one example. The other example
Mm-hmm.
is for weldments. You know, there are certain fixtures that you can make that help these guys out when they go to weld. In other words, if you have a box with four sides that need to be welded up, but you have a lid that needs to fit it, you know that you might make them a fixture that spreads that box, 15 thousandths at every corner, so that when they put that on there and they weld it, it comes back in and it fits that top.
Okay. Okay, that makes sense.
Yeah, and I'll tell you, just
Mm-hmm.
I mean, jigs and fixtures are the way that things get fabricated uh, precisely and accurately. You know, precisely
Mm-hmm.
being that they're done the same way every time. That's what people buy. They don't buy different products every time you go down to do something for any type of limited. And I haven't done full production, but limited production. If you have 10 parts, they all got to come out the same. So it's just a basic requirement that you make something, you have a stable setup, or you have a fixture that helps you make that part the same every time. And you have to originate that.
Okay, that makes sense. Hmm. Okay, and then you followed products through the prototype process from conception, fabrication, and assembly to testing the final production. How did you exactly oversee these processes and ensure best product outcome?
Well, the great thing about that company is that I had proximity to the manufacturing process. I mean, there was a front
Okay.
office, I was there. So typically at the stages of development, because I
Mm-hmm.
was a designer, I would go out and communicate with the people who were doing the work. I would take a look and see how things are going, if there's anything that I could do, to to overcome any kind of difficulties they were having. But basically, I have taken jobs from the front door and gone out the back door with them to do
Mhm.
everything involved, and it's an exhausting process. That's why they break it up into different guys doing different stuff. But yeah, so typically I would basically inspect those parts. I would keep an eye on those parts. I would see how they're coming out, make any changes that needed to be changed. But no, I would follow the job. I just didn't like hand it off and disappear.
So you were involved with all the steps.
All the aspects, yes. Sometimes I had to go out and do them if the guy didn't show up for work. I mean, it was one of those situations.
And did you identify any issues along the way that you had to resolve?
You know, the jobs were numerous, and there's always some difficulties involved. I mean, I really can't pinpoint one.
D-
Um,
on the top, from the top of your head, can you think of any one that was extremely extraordinary or memorable in one aspect or the other that you think is worth mentioning on the resume?
Let me
If
think.
not, it's perfectly fine. Yeah, take your time.
Yeah, nothing really stands out. I mean, typically, I
Mm-hmm.
was I was I was good in a design phase that we really didn't have major problems in the end. I mean, we just
Okay.
really didn't. We caught those halfway through. We caught those right at the beginning.
Okay. So we can move on to the next point,
Okay.
which is researched availability and application of hardware used
Yes.
in the design of mechanical. Can you please elaborate this?
Yes, this is basically nothing more than knowing that I have a requirement for a piece of hardware, or I need a linear actuator, or I need a strut. So basically, what you're
Okay.
doing at that point is, I mean, if you're smart, you go to the company and the application engineer, and you're able to communicate your needs either by drawings or whatnot, and they recommend that component for you. It's as simple as calling McMaster-Carr and saying, "Hey, look, I need a gasket. It needs to withstand this
Mm-hmm.
temperature and withstand these solvents or this environmental deal." And they will put you in touch with an application engineer, and you talk to that guy, and he recommends his product. Okay. Or if you have an adhesive to use, an epoxy, you look at the label, you look at the spec sheet, you look at the MSDS data, and you say, "Hey, this fits my job. I'm going to use it." or
Okay.
or I need to do something here. Do they make it? So you research. So you have a couple places you look, and you know who your vendors are: MSC, McMaster-Carr. If these guys aren't making it, it's no use trying to find some part off of eBay that you'll never be able to get again. So you cater your design to certain pieces of hardware or certain screws or certain components that you can get predictably, and you make the changes that you need to.
Okay. Okay. And okay, so you trained people here as well, I see. You trained associates in sheet metal and machining practices.
Yes.
So what methods did you use to train these associates, and how many people did you train collectively?
uh, I would say through the course of it, if someone was doing a job in which I had an expertise, whether it be sheet metal or
Mm-hmm.
um, um, any part of the finishing process or welding, um,
Mm-hmm.
I would, if they had problems, I would come out, and through my experience, typically we were able to resolve them. Or just basically, I studied those areas. I mean, not just, there's not always a school that you go to, but I had references and everything else that taught me mathematically how to do the job if they didn't know the formulas, or they didn't know, the rules of thumb to get that job done, because they just did things intuitively. I would go out there and enlighten them. I mean, nicely, if they asked, but yeah, but it's basically training someone to do the job that you have right now. So yeah, that was, that wasn't a specific incident. That was part of being a
Just
team player.
overall.
Yeah,
Mm-hmm,
overall, part
mm-hmm.
of being a team player, if I saw someone struggling and I knew how to do that job, they asked me for help, I would give it to them. I'm not a trade secret person. You know, a lot of them guys I
How
grew up